Hi class, in this video we are going to talk about correlations and experiments. Those are the last two things to talk about for chapter 2. They are the two most confusing things for students, and so even though you've heard of correlations, you've heard of experiments. And so the first thing I'm going to do is ask you a couple of questions so you can sort of get a baseline for what you know. So answer those questions now. And let's get into it. Correlations. What does it mean if you have a correlation, if you're doing correlational research? What it means if something is correlated, two things are correlated. It means that there is a relationship between those two things. That's all a correlation means. It means relationship. It does not mean cause and effect. If you have a correlation, you cannot say this thing caused that thing to happen. You just say they are related to each other somehow. So for example, a true correlation is, here, I'll show you a picture. So this is the rate of violent crime in the US and how much ice cream is being sold. There is a correlation between ice cream sales and violent crime. This is a true correlation. This is legit data. Just because there is a correlation, it does not mean ice cream causes people to be violent, and it doesn't mean if you're violent, you have to then go buy ice cream. There is a correlation, but there is no causation. There is no cause and effect relationship between these two variables. So keep that in mind. If all you've done is a correlation, you cannot say this thing caused that thing to happen. You have to go do an experiment in order to say that. So let's break down some of these definitions here. There are a lot. First one, correlation coefficient. Correlation coefficient is a letter, it's R, equals and then some number. That number can be any number between -1 and +1. You cannot have a correlation coefficient less than -1. You can't have it above +1. The correlation coefficient tells you two things about the correlation. One thing it tells you is the strength of the correlation, how closely those things are correlated. The way you tell the strength is you look at the absolute value of the correlation coefficient. So a correlation coefficient of -1 is just as strong as a correlation coefficient of 1. A correlation coefficient of -0.5 is stronger than a correlation coefficient of 0.3 because the absolute value of -0.5 is 0.5. You just erase the negative. And so the closer the correlation coefficient is to 1, so 1 or -1, the stronger the relationship is. What that means is it's easier to tell what one variable is based on what the other variable is. And when we get down to talking about scatter plots, this will make sense. I'll show you a picture. You'll understand about it. So one thing you tell from the correlation coefficient, the strength. The other thing you can tell is the direction. The direction is whether or not it is a positive correlation or a negative correlation. If the number is above 0, it's a positive correlation. It's a positive number. If the correlation coefficient is less than 0, it's a negative number. It means it's a negative correlation. For example, what it means if it's a positive correlation, before I get to the example. It means that if one variable goes up, the other variable goes up. They move together. If it is a negative correlation, what that means is that if one variable goes up, the other goes down. They move in opposite directions. So positive correlation, they move together. Negative correlation, they move in opposite directions. It's not a value judgment. Negative correlations aren't bad. Positive correlations aren't good. For example, the violent crime in ice cream sales. That is a positive correlation. The more violent crime there is, the more ice cream is being sold. If there is not violent crime, there's not a whole lot of ice cream being sold. That's not saying, yay, it's a good thing there's lots of crime and lots of ice cream sales. Not a value judgment. Positive only means they move in the same direction. They move together. An example of a negative correlation. The more Lucky Charms you ate as a kid, the less likely it is you have cancer today. That's a negative correlation. Lots of Lucky Charm eating, low rate of cancer. Just because it's a negative correlation doesn't mean it's a bad thing. We're happy we don't have cancer. It just means they move in opposite directions. When one of the variables is high, the other one is going to be low. An easy way to think about this is by looking at scatter plots. So a scatter plot is a picture, a graphical view of the correlation. And so I'm going to draw a couple for you here. I'm going to do this. Okay. So, for example, let's do a couple of ones here. First one we're gonna do, what you do for a scatter plot. You have your two variables here. So for example, let's do a positive correlation. We'll do a different one. The more you study, the higher your grades are. It's a true correlation. That one, it is cause and effect, but if all you've done is a correlation, you can't say that. You can just say there's a relationship. So what you do is you have, on one side, you're going to put the variable. So we'll do studying here. And then on the other one, you put grade on test. And then you go around and ask people, how much did you study? I studied a lot. What was your grade? It was pretty good. And you just go and you talk to people, and it's gonna look something like this. Of course, you always have someone who doesn't study and still does awesome. And someone who studies a lot but then doesn't do so great. But generally speaking, it's going to be like this. This is going to be a strong correlation. The correlation coefficient for this is going to be something like R equals, that'd be something like 0.8. So that's the correlation coefficient for this. You know it's a positive correlation because when you're low on one, you're low on the other. When you're high on one, you're high on the other. They move in one direction. And you know it's going to be a higher one because they're pretty close together. If it was something like this, that correlation coefficient is going to be something more like 0.4. It's not as strong. It's harder to tell if you know one variable what the other one is because there's lots of options for what it is on the other variable. So again, the strength, how much they move together, these ones don't move together as well. It's a lower correlation. Now let me show you an example of a negative correlation. So I'll redraw this. Okay. So an example of a negative correlation, we'll do the Lucky Charms and cancer rate. So you go around and ask people how much Lucky Charms you had as a kid. Do you have cancer today? And the people that had a whole lot of Lucky Charms as a kid, less of a cancer rate. And then, of course, you always have a few exceptions, but it'll be something like that. So that would be a negative correlation. This would be something like R equals negative 0.5. But negative correlation, again, when you're high on one, you're low on the other. They move in opposite directions. As this one gets higher, this one gets lower. But looking at a scatter plot, it can tell you what's going on here. And like, for example, if you see something like that on the scatter plot, you want to go study those people. What is up with those people that makes them so much different than the average? So that's scatter plot. Next thing is, again, briefly going over this cause and effect part. Remember, you're just talking about a relationship. What often happens is that people do correlations first, see there is a correlation, and then they go and do an experiment to see cause and effect. Oftentimes, if there is no cause and effect, like ice cream and violent crime, like Lucky Charms and cancer rate, Lucky Charms does not prevent cancer. What is happening is that you have a confounding variable. And what a confounding variable is it's when some other factor is actually causing the movement in these variables. And so, for example, for ice cream and violent crime goes up in the summer. Ice cream sales go up in the summer. So the confounding variable there is heat. The hotter it is, the more violent crime you have. I talk about this in my social psychology class. It's the frustration aggression principle. When you're hot, you're more likely to be aggressive. And so heat leads to higher ice cream sales, leads to higher violence. For Lucky Charms and cancer, this has to do with your age. Your grandparents didn't have the option of eating Lucky Charms because Lucky Charms didn't exist when they were kids. Lucky Charms is a newer thing. Like my generation's the first that really had Lucky Charms as an option. And so, well, I'm not young, but the younger you are, the less likely you are to have cancer. So age is the confounding variable for both of those. The chances you ate Lucky Charms, the chance you have cancer now. So that's what confounding variables are. Illusory correlations are false correlations. It is when you think there is a correlation, but there isn't. Examples of illusory correlations is the idea that people act stranger when there's a full moon, that, you know, more people get arrested if there's a full moon. No, there is no relationship between the full moon and your behavior, but people kind of think there is. If you, when you watch, I don't know, I'm a Red Sox fan, but probably more of you are Orioles fans. If you're watching an Orioles game and you think if you wear your lucky socks, they're more likely to win. You think there's a relationship between your sock wearing and the outcome of the game. That's an illusory correlation. Your socks have nothing to do with it. So when you think there's a correlation and there's not, illusory correlation. A confirmation bias is when you think there's a relationship between two things, and so you seek out evidence to back up your assumptions. So you find information that backs up what you think, and you ignore information that doesn't back up what you think. So, for example, and then, I mean, sometimes this can relate to illusory correlations too, because you just want to find proof that your belief is right when it's not. Like, for example, the idea that vaccines cause autism. That's an illusory correlation. There's absolutely no relationship between, or that is an illusory correlation. Getting vaccines is not more likely to cause autism. The age at which you tend to get vaccines is also the age at which they tend to diagnose you with autism. So that could be a confounding variable, but there's no correlation there. You are not more likely to have autism diagnosis if you've been vaccinated. But if you are someone who thinks that vaccines are dangerous and going to cause autism, you are going to seek out anyone you know who got diagnosed with autism soon after getting a vaccine. And you're going to say, see, look, here's someone I know who had that happen. Or with the COVID vaccine, if you don't think it helps, you can, search out, I know someone whose grandma died even though she was vaccinated. See, look, vaccines don't do anything. You attach yourself to that information and you ignore all the millions of cases, all the stats that show if you're vaccinated, you're less likely to die. And you just focus on what kind of proves your point. That's confirmation bias. And that is it for correlations. Final thing to go over this chapter is experiments. For experiments, this is the cause and effect. If you do an experiment, you can say this thing caused that thing to happen. There are some definitions you need to know for an experiment. And hold on one second. Yes, okay. When you do an experiment, you have to design your experiment. You have to have an experimental group. Oftentimes, you also have a control group. Not every experiment's going to have a control group. Most do. You have to have an experimental group. An experimental group is the people who get manipulated. They get the treatment. You are changing something about them, their behaviors, the medicine they take, whatever it is. You're screwing with the people in the experimental group. If you have a control group, these are people who don't get the manipulation. So if you are seeing if a new drug helps with depression rates, your experimental group gets the new drug, the control group doesn't get the new drug. You're not messing with them. They don't get the treatment. So you always have an experimental group. Sometimes you have a control group. The operational definition, this is how you describe your variables and how you are going to measure your variables. So for example, so I'm going to use the example of my perspective taking experiment. So for example, I was working in Rwanda and I realized that, and I was working with genocide survivors. And I realized that the genocide survivors, the ones who talked about the bystanders of the genocide, so the people who weren't targeted and didn't participate, but also didn't help out, that kind of just sat back and said, not my thing. The survivors had very different views of them. Different survivors felt differently about bystanders. Some of them were still very, very angry. This was about a decade after the genocide. They were still very angry, like how could they just be bystanders? How could they just sit back and watch us get slaughtered? And then some of the survivors couldn't understand, like if they had tried to help, they would have been killed too. They were focused on keeping their own kids safe, and they were too scared to risk saving me and my kids, or me and my parents. And so I saw this correlation. I said, hey, there seems to be this correlation here. If they can understand what the people have gone through, or when they can understand it, then they seem to have more forgiveness for them, or less unforgiveness. Again, I'm a pessimist. And so I decided to do an experiment to see what caused what. Is it people who forgive then are able to understand the perspective of the person that they think wronged them? Or if you take the perspective of the person that you're upset with, does that make you have less unforgiveness for them? And so in this, my operational definition, I had to be very specific. I am focusing on decreasing unforgiveness levels. If I just said, taking the perspective of the other person means you forgive them, what does forgiveness mean? Does it mean you have to be hanging out with them? Does it mean you have to consider yourselves friends again? what do you mean? What are you measuring when you say you have forgiven someone? Or in my case, when you have decreased unforgiveness. So my operational definition had to be very specific. I am measuring levels of rumination, how much you think about the other person, and avoidance, how much you want to not be near them, and revenge thinking, how much you want them to hurt the way they hurt you. I had to be very specific. Here are the things I am measuring when I say unforgiveness levels. Because there's a whole lot of things that could fall into that. You have to be very specific. When I talk about perspective taking, here is exactly how I'm doing it. I can't just say, what do you think this other person was thinking? I had a very specific technique of how many times they had to tell me what happened, pretending to be the other person, how much they had to make sure they were using that person's perspective, like saying I instead of saying they, all that sort of stuff. So your operational definition for experiments, you have to be very specific on what you're measuring, how you're going to measure it, and when we get to talking about replication, it will connect with that as well, but you have to be specific. And for this, there's a couple of types of bias you got to think about. Experimenter bias is when the experimenter is biased, unintentionally, potentially. It's the researcher's expectations might skew the results of the experiment. And so there are ways to mitigate experimenter bias. You can have a single blind study. A single blind study is when the participants don't know what group they're in. The participants don't know if they are in the experimental group or they're in the control group. For example, if you're doing a procedure, trying out a medicine, the people in the experimental group get the medicine, the people in the control group get a placebo. They get like a sugar pill. So neither group knows if they're getting the real thing or a fake thing. That's a single blind study. The participants are clueless. If you're also worried that the participants' assumptions can have an effect, participant bias, then you might do a double-blind study. In a double-blind study, neither the participants nor the researchers know who is in either group. So everyone is sort of clueless. If you do a double-blind study, like for a medicine study, the researcher handing the person the pill doesn't know if they're handing the real medicine or a sugar pill. They know that this is group A and that's group B, and group A gets the blue pill and group B gets the red pill, and somewhere in a filing cabinet it says group A is real medicine, group B is sugar pill. But you have to wait till the experiment is over, till a certain amount of time has passed before you go look in that file cabinet and see who was in each group. So hold on, I said that wrong. Single blind studies help with participant bias because the participant is clueless. If you're worried about experimenter bias, then you're going to do the double blind. Then you're going to set it up so that the researcher is also blind to what's happening. For non-medicine studies connected with this, for example, I had a friend who was studying, I had a lot of side hustles in grad school. I helped out with a lot of research and did other stuff. I had a friend hire me to participate in her study, to be a researcher in her study. She was looking at growth mindset versus fixed mindset, and how giving a lesson emphasizing growth mindset, using growth mindset techniques or fixed mindset techniques would affect comprehension in kids. So if you use words connected with growth mindset, those techniques, the kids will remember more of what you tried to teach them. Again, this was grad school, didn't have kids, didn't care, never going to be a teacher to little kids. Whatever. So my friend hired me to give the lessons. And she didn't tell me what her experiment was about before I gave the lesson. She just said, here's a script to memorize, teach it to these students. Here's a script to memorize, teach it to those students. But I didn't know her hypothesis. I didn't know what she thought was going to happen. So that was a double-blind study. The person interacting with the participants was clueless. So you'll often see double-blind studies. It's especially common in things like medical research. All the vaccine studies that were done were double-blind studies. The researchers who were giving people the vaccines had no clue if they were giving them saline or the actual vaccine. The participants didn't know until it was all done. The reason you'd have a control group with this double blind is because of the placebo effect. The placebo effect is when your expectations influence your experience. This is, when my 6-year-old daughter scrapes her knee and I kiss it and it feels better. That's placebo effect. My kiss is not magic. It didn't do anything, but she thought my kiss would help, and so it did. So the reason they give things like a placebo, like a sugar pill to a group, is because sometimes just taking a pill makes you feel better even if the pill's not doing anything. Your expectation that pill is going to help might have an effect. Or for example, in my unforgiveness study, perspective taking and unforgiveness study, I had my experimental group who got my manipulation. They had to come in and tell me what happened, pretending they were the other person, and I measured their unforgiveness before and then 3 weeks later. And then I had a control group because I thought just coming in and talking about it, knowing you were participating in a study where you were recruited because you hadn't forgiven somebody for something, people were going to expect that whatever happened was going to help with that. There would be a placebo effect. So I had a control group that came in and they just told me what happened from their own perspective. So this was a single blind study. They didn't know if they were control group or experimental group. They just came in and talked. But they didn't take the perspective of the other person. They just told me from their perspective. And I measured their unforgiveness before and 3 weeks later. And then at the end, I compared the unforgiveness levels for the group who had taken the other person's perspective and from their own perspective. And the people who did the perspective taking had lower levels of unforgiveness. They had forgiven the people more if they had to see it from the other person's side. So just a little more here, a few more definitions, and then we're gonna do a couple of examples. One, independent and dependent variable. The independent variable is the thing you manipulate or control. So you determine the independent variable and you decide who gets it, what level it is. The dependent variable is what you measure at the end. And it is what you think is affected by the independent variable. So the easiest way to tell these apart, independent and dependent variable, is put your hypothesis in the phrase, this has an effect on that. So for example, with my perspective taking study, my research question or my hypothesis was perspective taking has an effect on unforgiveness levels. And so if you have that, perspective taking has an effect on unforgiveness levels. The independent variable is the initial thing. The dependent variable is dead last. So perspective taking was my independent variable. Unforgiveness levels was my dependent variable. So that's an easy way to tell which is which. And your participants, these are the people in your study. They used to be called subjects, but that was, I don't know, making them sound like lab rats, and they're people. So we call them participants now. When you do an experiment, you have to have a random sample. We talked about this in the last video. Random sample. Your sample looks like your population. Remember that. It's got to look like who you're interested in. This is one problem with a lot of experiments because honestly, the vast majority of psychological experiments take place on college campuses because that's where most psychology researchers work. They're professors. And so the vast majority of participants are college students. And I mean, y'all are great, but you are not the average population. Just because a bunch of 20-year-olds act this way does not mean everyone in the US would act this way. You are younger, you are more diverse, and you have more education than the average population. Those could be confounding variables. And then random assignment. This is when all participants have an equal chance of being asked to participate in the experiment. So, for example, in my perspective taking experiment, my participants really ranged in who they hadn't forgiven somebody for something. For example, one participant was mad at her roommate from the last semester who would study with the light on really late. And then there were participants who were mad at a parent who had left and just didn't have a relationship with them anymore. I mean, you know, big range. In my experiment, ideally, the people in my control group aren't going to forgive a lot because they're not getting the manipulation. And the people in my experimental group are going to forgive a lot because they are getting the manipulation. However, in order to be ethical, I can't choose everyone I think is going to forgive to be in my experimental group and everyone who I think is not going to forgive to be in my control group. It has to be randomly assigned. In my case, I did every other person. One person experimental, one control, and I just went back and forth. And if your treatment really works, you're going to see an effect. And in my case, I did. Taking the perspective of the person who hurt you does help you decrease unforgiveness. So even if it was the more intense types of events, the people in the experimental group had higher reductions, higher levels of a reduction in their unforgiveness. Okay, so the final thing we're going to do for this is I am going to show you a little video. And then after that video, I'm going to ask you some questions about it. The questions I'm going to ask you, just so you know, what I want you to keep an eye out for as you watch this. What is the experimental group? Is there a control group? If so, who are they? What's the independent variable? What's the dependent variable? Who's in the sample? Who's in the population? So again, what's the experimental group? What's the control group, if there is one? What's the independent variable? What's the dependent variable? What's the sample? What's the population? So watch this video and answer those questions. Oh no. And now, last couple things to go over. One, a quasi-experiment. A quasi-experiment is when you can't randomly assign the people to the levels of the independent variable. For example, in my experiment, I could say, you take the perspective of the other person, you don't take the perspective of the other person. But what if you are studying whether gender has an effect on study habits? So your independent variable, does gender have an effect on study habits, is gender. Dependent variable, study habits. You can't assign people to gender. You can't say, you are male, you are female, you are non-binary. You just find people who already have that gender. And so you find people who are at the levels of your independent variable rather than assigning them to the levels. That is a quasi-experiment. Another thing to think about is the ethics. You can't do an experiment that would be unethical, that would hurt people. For example, what is the effect of lead on prenatal development? You can't go and force a bunch of pregnant ladies to ingest lead to see what happens to the kids. That's unethical. So there are some things you cannot do as experiments because it would be unethical to the participants. Another thing to think about is reporting it. After you do the research, you submit the research to peer-reviewed journals, which means other people review your research and make sure it's legit to get it published, whether it is done well or not. A big reason for this, besides to let people know, hey, this is what I found, is so that they can replicate it. Replication is when other people go and do your experiment to see if it works here. For example, my perspective taking study was actually a replication with a caveat. Someone else had done this experiment and found that perspective taking helps with forgiveness. My research participants, the community I worked with were Rwandan genocide survivors. Rwandan genocide survivors potentially, I thought, could be different than college students in a New England town where that experiment had been done. So in my version, it was a replication using sub-Saharan Africans as my research participants to see if it still worked using a different demographic. Also, that's one reason why you have to be so good with the operational definitions because people have to be able to come and do your research as well. Also, you need to know the difference between reliability and validity. Reliability is when you get the same results over and over again. Your book defines it as the ability to consistently produce a given result. So each time you do it, you're going to get the same results. For example, in my study, I used a scale to measure unforgiveness. It's called the TRIM, transgression related, oh gosh, I can't remember. Anyways, it's called the TRIM 18. It measures unforgiveness levels. If I give it to you today, and then I give it to you tomorrow, nothing happens in between those 2 days. Your score should not be drastically different. If it is reliable, you're going to get about the same score today and tomorrow, because unless something big happened to change your unforgiveness. If it's reliable, you consistently get the same results. If it's valid, that's the extent to which your instrument, your measure, whatever, accurately measures what it's supposed to. So if my TRIM 18 is valid, it's actually measuring your unforgiveness. If you, for example, if you use shoe size to measure intelligence levels. So people, I have short feet, so we'll do a negative correlation. The smaller your feet, the smarter you are. Questions for you. Is that a valid, or actually, yeah, no, we'll start with valid. Is that a valid intelligence test? Is that a reliable intelligence test? It is very reliable because if I measure your shoe size today and I measure your shoe size next week, I'm going to get the same score. So it's reliable, but it's not valid. Shoe size has nothing to do with intelligence levels. So in order to be right, you want both validity and reliability. And then finally, a little bit more connected with the ethics, you'll learn about some unethical studies that have been done in psychology. In order to help make that not happen, some measures have been put in place. One is the institutional review boards. If you are going to do a research experiment, you have to have that proposal approved by the IRB at your school. McDaniel has an IRB. They make sure you are doing something ethical and that you're not going to hurt your participants, that it is a safe study to do. When you do an experiment with human participants, you have to have an informed consent. You have to let people know what they're getting into. It's a description of what's going to happen, any potential risks. Sometimes you have to lie to people in studies. This is called deception. For example, in my study, I couldn't say I'm studying whether perspective taking helps with reducing unforgiveness, because if you aren't taking someone's perspective, then you know you're not in my experimental group. So I had to be vague about it. That was only slight deception, not a big deal. But sometimes you have some pretty big deception in studies. Sometimes it's very important, but it adds ethical considerations, because if you're lying to them, they can't give legit informed consent because they don't know what they're actually consenting to be a part of. You always have to have a debrief at the end where you explain exactly what happened. If you lied, if you had deception, you tell the truth, what you were actually studying. There can be other things like how the data was collected, what the data will be used for, how it's going to be stored. For example, since most of my research participants are genocide survivors, part of the debrief is also giving them access to free counseling if they need it, because a lot of my research is connected with genocide. So lots of different things, but you have to debrief at the end. And that is it for this video.